So bookkeeping number 2, knowing which quantities are state functions. State functions are really nice because these are functions that only depend on the current and the final state of the system and not how it got from here to there. This is really nice because what you can do is you can measure it, you can turn your back and twiddle your thumbs as things happen, and it doesn't really matter what's happening. You come back, you measure the final state of the system, and that's all that matters. What happens in between doesn't matter. Example, some simple quantities that are state functions. There's no football this year, but frequently there would be football. So the yards along the path the football player ran to get to a point is not a state function because they could take any number of circuitous paths to get from the 20-yard line to the 50-yard line. They could take just 30 yards or it could take much longer if their quarterback scrambling. The yards gained on a football play, however, is a state function. If, all it depends, the yards gained is, where did you start the play and where did you end the play? So that's an example of something that is a state function. All that the current position on the field is a state function. What happened during the play, the yards traveled, is not a state function. So book could be number 2. So why do we care about state functions? The energy of a system is a state function. It doesn't matter how it got there. It only matters what the current, what atoms that are, where the what atoms are in there, what state the atoms are in, what the temperature is, what the volume is, what the pressure is. If you can describe the state of the system, then you know if you know the physical conditions of the system, you know its energy. If we cool, heat, or react an isolated chemical system, and it starts and ends in the same state, no matter how it got there. If we have a certain number of moles of chemical A and chemical B, and then they react to form C, and then we dump a bunch of other stuff, and then we take it out. If at the end, no matter how we got to our new set of whenever the end of the reaction is, or the end of 18 different reactions, if there's 2 different ways to get the same final composition, the change in energy from the initial composition to the final composition will be the same. So this is very useful in a lot of thermochemistry things because we can make up a way to get from A to B. We can find the easiest way for the system to change from state A to state B and calculate that rather than looking at what it actually did. So that's really powerful. Doesn't matter how it did it. We can make up our own way that's easier to deal with. And the change in energy will be the same.